Ever felt like the way your web application handles its data could be, well, smoother, maybe more powerful?
Yeah, it's a common challenge.
Today, we're diving deep into the heart of many Ruby on Rails applications,
Huh.
how they actually talk to their databases.
And what's really interesting here, I think, is the elegant abstraction Rails provides. It simplifies this really crucial interaction.
Right.
We're going to explore Active Record, which is the Object-Relational Mapping system, the ORM that's built right into Rails.
Okay.
Think of it as this sort of intelligent intermediary. It sits between your Ruby code and the, structured world of databases like PostgreSQL and MySQL.
And it's not just about making development easier, is it? Because as your application scales up, maybe even to millions of users, like we'll hear about,
hmm
the choice of database and how you use it through Active Record, that becomes a huge factor for performance.
Absolutely critical. Precisely. So for this deep dive, we've pulled together a pretty comprehensive set of resources. We'll be looking at the official Active Record Basics Guide from Rails, a detailed benchmark comparing Active Record, and another ORM called SQL, specifically with Timescale DB.
Okay.
Also a practical guide on using MySQL with Rails, a pretty revealing Reddit discussion about which databases Rails devs actually prefer.
Ah, interesting. Real-world takes.
Exactly.
Mm.
And an insightful article on optimizing database performance, looking ahead to Rails 8, plus a fascinating interview about scaling Rails and Postgres in a massive environment at Microsoft, no less.
Wow, okay. So quite a range there.
Yeah.
So the goal, our mission for this session is for you, the listener, to get a really solid grip on Active Record fundamentals, how it plays with different databases, and crucially, the key strategies for building Rails apps that aren't just functional, but really performant.
That's the plan.
Okay, let's dive in then. What exactly is Active Record in, like, a nutshell?
Okay, so at its core, Active Record is really a cornerstone of the Model View Controller pattern, the MVC architecture that Rails is built on.
Right, the classic MVC.
Yeah. It represents the model layer. That's the part of your app responsible for handling the data itself and also the business logic around that data. Understanding this layer is just key.
Now, I've heard the term active model thrown around too. Are they the same thing, or is there a difference?
Good question. That's an important distinction. They both live in the M of MVC, you could say, but they do different things.
Okay.
Active Record is specifically for Ruby objects that need to be saved, persisted, retrieved from a database.
Got it. Database backed.
Exactly. Active Model, on the other hand, provides a framework for objects that represent data but don't necessarily need database storage. Think form objects, maybe handling user input before it gets saved.
Okay. So active record indexes database models, and this relates to the active record pattern itself. What's that pattern about?
Precisely. The active record pattern, which Martin Fowler sort of formalized, describes an object that essentially wraps a single row in a database table.
Okay, like a Ruby representation of a row.
Exactly. And it doesn't just hold the data. It also contains the logic for accessing and manipulating that data, plus any business rules tied to it. So your active record classes in Ruby closely mirror your database table structures.
Okay, so it makes interacting with tables feel more like working with Ruby objects. And that's where Object-Relational Mapping, ORM, comes in.
You got it. ORM is that technique of bridging the gap, between the object-oriented world of Ruby and the relational world of databases. Active Record is the ORM framework within Rails.
Right.
It lets you work with data using Ruby objects, and Active Record handles translating that back and forth into SQL commands behind the scenes. It drastically cuts down the amount of raw SQL you need to write.
That sounds incredibly efficient for development. So
Yeah.
I can mostly just write Ruby, and Active Record deals with the SQL bits.
For the vast majority of interactions, yes. Absolutely. But having a basic understanding of relational databases and SQL itself, that can be really valuable.
How so?
Well, it helps you understand how Active Record works under the hood, and it's super useful for, say, optimizing tricky queries or troubleshooting weird issues.
That makes sense. Good to know what's happening underneath. So what are the main things Active Record actually does? What core functionalities does it give us?
It provides a whole suite of features, really. It lets you represent your database tables as Ruby models, define the relationships between those models. We call those associations.
Okay.
It helps manage inheritance if you have related models, lets you implement data validation rules to keep your data clean, and perform all the basic database operations, create, read, update, delete, but in a more object-oriented way.
Okay, it handles a lot of the data management heavy lifting. Now, Rails is famous for convention over configuration.
Mm-hmm.
How does that apply to active record and databases?
Oh, it's fundamental to Active Record. It starts right with naming things. Rails uses specific naming conventions to automatically link your Ruby model classes to your database tables.
Like magic.
Sort of. For instance, if you create a model class named book, Rails just assumes, using a helper method called pluralize, that it maps to a database table named books.
Ah, so book becomes books. Simple enough.
Exactly. Understanding these conventions saves you a ton of manual setup. Rails is pretty smart about handling pluralization too, even some irregular English words.
That is convenient. Just follow the naming rule and Rails connects the docs.
Pretty much. And beyond naming, there are schema conventions too. By default, Active Record expects every table to have a primary key column called id.
Right, the unique identifier.
Yeah, and it's usually an integer. Well, actually, for PostgreSQL and MySQL these days, it's typically id instant gives you a much bigger range of IDs. SQLite uses a standard integer.
And Rails creates this id column automatically.
Yep, when you use Active Record migrations to create your tables, which is the standard way, that id column is automatically generated for you.
Okay. What about relationships between models? Like, if a book belongs to an author, how does it know how they're linked in the database?
Good question. For those relationships, Active Record looks for foreign key columns. The convention here is the singular name of the related table, followed by id.
Ah, so for a book belonging to an author, the books table would need an authority column.
Exactly, authority. That tells Rails how to link a specific book back to its author.
Got it. Plural table name books, singular foreign key authority. Any other schema rules to watch out for?
Yes, one big one. Avoid using reserved words for your column names. A common one is type. Rails uses the type column internally for something called single table inheritance, or STI.
Okay.
So unless you're specifically doing STI, don't name a regular column type. It can cause confusing problems down the line. Choose something more descriptive.
Good tip. Steer clear of reserved words like type. So how do we actually create these active record models in a Rails app?
Right. When you start a new Rails app, you'll find a file app model application record.rb. This is an abstract class. It inherits directly from active record.base. And by having your own models inherit from application record, they get all the active record powers, the database connection, the query methods, everything.
So all my apps models should inherit from application record.
That's the standard practice, yes. So to make our book model, you just create a file, say appmodelsbook.rb with a simple class definition. Class book application record end.
And that's it. That tells Rails this book class maps to the books table.
Yep. And Rails knows that the columns of the books table should be available as attributes on instances of this book class.
So I don't need to write the create table books, SQL myself.
Not usually, no. The Rails way is to use active record migrations to manage your database schema changes.
Migrations, right.
So to create that books table with, say, title and author columns, you'd run a command in your terminal. Bin Rails generate migration, create books, title.string, author.string.
And that command creates a Ruby file.
Exactly. It generates a migration file, usually in the DB migrate folder.
Oh.
This file contains Ruby code that describes the database change.
What would that code look like?
For that example, it'd probably look something like create a table.books do tt.string.title t.string.author t.timestamps end.
Okay, I see. Create table title author. What's t.timestamps?
T-timestamps is a handy shortcut. It automatically adds 2 columns. Created update at. Rails will manage these timestamps for you, recording when a record was first created and when it was last updated.
Nice. So that migration creates the primary key, title, author, created at, and updated columns.
Precisely. You run the migration using binrails db.migrate, and Rails translates that Ruby code into the right SQL for your database, Postgres, MySQL, whatever, and creates the table.
Yeah, and then my book model can immediately interact with that too.
Yep. You could jump into the Rails console, binrails C, and do something like book.new, then book.title The Hobbit, and see the attribute assigned. Later, you call book.save to actually put it in the database.
Very streamlined.
Yeah.
Now, I think I saw a command that creates the model and the migration at the same time.
Yes, that's a useful shortcut. BinRails generate model book title dot string author dot string.
Generate model instead of generate migration.
Right. It does both. Creates the app models book.rb file and the corresponding migration file in dbmigrate, plus some basic test files too. Saves a couple of steps.
Definitely handy for getting started quickly.
Yeah.
What about organizing models? If my app gets big, I might want folders within app models. You mentioned namespaced models.
Yeah, exactly. As apps grow, you might want to group related models. You could create a book directory inside app models and put related models like order.rb or review.rb inside that directory.
Okay.
The class names would then reflect this structure, like book.order and book.review. Rails fully supports this namespacing.
How does that affect the database table names? Does book.order look for a book orders table?
By default, no. Book.order would still look for a table named orders.
Oh, okay.
But you can customize this. You could define a prefix in the parent module, the book module. In app models book.rv, you might add self.tablename prefix, book. Then book.order would map to book orders. Or, even simpler, you can just explicitly set the table name right inside the namespace model. Class book.order application record, self.tablename, book orders, end.
That gives you flexibility.
Mm-hmm.
Okay, but what if I'm working with an existing database? Maybe a legacy one that doesn't follow these Rails conventions at all.
Great question. That happens a lot. This is where overriding the default conventions is essential. Since your models inherit from ActiveRecord.base via application record, they get methods to customize these mappings.
So if my table is called, I don't know, legacy book catalog instead of books?
No problem. Inside your book model definition, you just add this line, self.tablename legacy book catalog. That explicitly tells ActiveRecord which table to use.
Simple enough.
One important note, though. If you do this, you also need to tell your tests about it. In your test file, you'd use something like setFixtureClass legacy book catalog. So your test fixtures load correctly.
Okay, good detail. What about the primary key? If it's not KID, maybe it's bookCUID or something.
You can override that too. Use self.primaryKey bookCUID in your model.
Yep.
But be very careful here. ActiveRecord strongly recommends not having any other columns named id if they aren't the primary key.
Why is that?
It can cause confusion and conflicts. If you have a non-primary key column named id, you might need to access it using a special alias like id value to avoid ambiguity with the actual primary key method.
Sounds messy.
It can be. In fact, Rails migrations will actually stop you from creating a non-primary key column named id unless you explicitly turn off the automatic id primary key generation using id upon false in your creatable block.
Wow. Okay, so they really discourage that id naming collision.
Yeah.
Good to know. So models are defined, connected to tables. Now, how do we actually manage the data? The CRUD operations.
Right, CRUD, create, read, update, delete, the fundamental actions you perform on data. ActiveRecord makes these operations really straightforward with high-level methods that hide most of the SQL complexity.
Let's start with create. How do we get new data into the database?
Two main ways. First, you can use the new method, book.new_title. This creates a Ruby object in memory, but it's not saved yet.
Okay, but just temporary.
Right. You set its attributes, book.author=save, and then you call book.save. That's when ActiveRecord generates the insert SQL and saves it to the database.
So new, then save. What's the other way?
The create method. It does both steps in one go. Book.createTitle, not to title author. It instantiates the object and saves it immediately.
More concise.
Yep. You can also use blocks with both new and create if you prefer that style for setting attributes. Book.create, do b title, and indent.
And when a record is created, those created dat and updated dat timestamps get set automatically.
Exactly. If those columns exist, ActiveRecord handles setting their initial values on create.
Cool. Okay, that's creating. What about reading data back from the database?
ActiveRecord has a really rich API for querying. It's quite powerful.
Not getting everything.
Yep. Book alt fetches every record from the books table. It returns an ActiveRecord relation object, which is like an array of book objects.
What about just one?
You can get the first or last record based on the primary key order using book.first and book.last. Or book.take grabs an arbitrary record. These usually translate to select statements with order by and limit one in SQL.
Okay. What if I need a specific book? Like find the book with ID 42 or find a book by its title?
Good use cases. For finding by ID, you use find. Book.find42. This will return the book with ID 42. But, crucially, if no book with that ID exists, find will raise an error in ActiveRecord, record not found exception.
Oh, okay. So it assumes a record must exist.
Right. If you want to find by other attributes, and it's okay if nothing is found, you use find by. For example, book.findBy, title, metaprogramming Ruby 2. This returns the first matching book, or nil if none match. No error.
Find for mandatory finds, find by for optional finds. Makes sense. What about finding multiple books that match criteria, like all books by a certain author?
Here the where method shines. It's super versatile. Book.where author Douglas Adams. This returns an ActiveRecord relation containing all books by Douglas Adams.
And I can chain things onto that, like sorting.
Absolutely. Book.where, author douglasadams.order, created.desk. This finds them and then orders them by creation date, newest first. It generates a select with both where and order by clauses.
Wow, that seems powerful. You can build complex queries without writing SQL.
Exactly. And there's way more grouping, joins, selecting specific columns. The active record query guide is the place to go for all the details.
Okay, we can create, we can read. How
Yeah.
about update? Changing existing records.
Simple enough. First, you retrieve the object you want to update using find by, where, whatever. Let's say you have book.find 10.
Got the book object.
Then you just change its attributes directly in ruby.title, book.title.
New title.
Just like setting it on new.
Yep. And then, just like with new, you call book.save to persist the change. Active record figures out it's an existing record and generates an update SQL statement.
Okay. Is there a shortcut like create? Yes, there's the update method, book.update, title, new author, new author. You pass a hash of attributes and it updates them and saves in one step.
Nice. And does updated automatically too?
It does. Whenever you successfully save or update an existing record, the updated timestamp is automatically refreshed to the current time.
Perfect. So that covers create, read, update. What about the delete?
Right, delete. The source guide we looked at didn't explicitly detail it in the main CRUD section, but Active Record definitely provides ways to delete records.
How does that work typically?
Once you have an object, say our book object again, you just call the destroy method on it. Book.destroy.
And that removes the corresponding row from the database.
Exactly. It generates and executes a delete SQL statement for that specific record's primary key. There are also methods like destroyal or deleteal that you can use on collections, like the result of a where query, to remove multiple records at once.
Okay, so the full CRUD lifecycle is covered. Now, I saw something about callbacks in the docs. What are those for?
Ugh, callbacks. They're quite powerful. They're essentially hooks that let you trigger your own custom code at specific points in a model's lifecycle.
Lifecycle, like when it's created or saved.
Exactly. Events like before validation, after creation, before update, after save, after destroy. There are quite a few hooks. Callbacks let you automatically run logic tied to these moments.
Can you give an example? What would you use that for?
Sure. Imagine you have a user model. Maybe every time a new user signs up and is created, you want to, say, send them a welcome email or log the event somewhere.
Okay.
You could use an after create callback. In your user model, you'd add something like after create.send welcome mail. Then you define a method send welcome mail in that same model.
And that method gets called automatically after a user record is successfully saved for the first time.
Precisely. It hooks into the save process. Here's a simple logging example from the guide. Ruby.class user application record after create.loguser.after create.private after create.def longuser.after create.puts. A new user was registered at hashtag time.now after create end after create.end.
Ah, okay. So whenever user.create succeeds, that puts statement runs.
Yep. You'd see that message in your logs. It's a way to encapsulate logic that always needs to happen when a certain event occurs for that model. The callbacks guide has the full list of available hooks.
Seems really useful for keeping related logic together with the model. Okay, shifting gears slightly, managing the database structure. That's migrations, right?
Exactly. Migrations are Rails' way of managing changes to your database schema over time in a structured, version-controlled way.
Instead of writing raw alter table SQL commands.
Right. You write Ruby code in migration files to describe the changes, add a column, create a table, add an index. Rails then translates this Ruby into the correct SQL for whatever database you're using.
So the same migration file works for PostgreSQL and MySQL.
Generally, yes. That's a big advantage. It makes your schema changes database agnostic. You define the what in Ruby, and Rails figures out the how for the specific database.
How does Rails know which migrations it's already run?
It keeps track in a special table in your database, usually called schema migrations. It records the version identifier, usually a timestamp from the file name, of each migration that has been successfully applied.
So when you run bin Rails, db.migrate.
It checks that schema migrations table, looks at the files in your db migrate folder, and only runs the ones that aren't listed in the table yet. Ensures each change happens only once.
And you can undo migrations.
Yep, bin Rails db.rollback typically reverts the last migration that was run. Again, the migrations guide have all the details on creating and managing them.
Okay, so migrations handle the schema. What about the relationships between the data in different tables? That's associations.
Precisely. Associations are how you define the connections between your different active record models. Things like one-to-one, one-to-many, many-to-many relationships.
Like our author and book example, an author has many books.
Exactly. You declare that relationship directly in the model files. In the author model, you'd put has many.books.
Just that line.
Yep. And in the corresponding book model, you'd usually put belongs to.author. These declarations tell active record about the connection.
And what does that give you?
It adds a bunch of helpful methods automatically. For instance, on an author object, you'd get an author.books method that returns all associated book objects. On a book object, book.author would return the associated author. It makes navigating between related data really easy and intuitive in your Ruby code.
Ah, so author.books would fetch all the books with that author's authority.
Essentially, yes. Active Record generates the necessary query behind the scenes based on the association you defined. The associations guide covers all the different types. Hozone has many belongs to, Hozone's belongs to many has many.through, and how to use them.
That sounds incredibly useful.
Okay.
We've covered Active Record itself pretty well. Let's talk databases. Rails defaults to SQLite, but people often use PostgreSQL or MySQL in production. What are the trade-offs?
That's a critical choice. SQLite, the default, is great for getting started, for development, testing. It's just a file, super portable, no server needed.
But limitations?
Yeah. The big one is concurrency. It typically only allows one write operation at a time, which can be a bottleneck under load. It also lacks things like user management and network access you often need in production. It's not really built for high-volume, multi-user web apps.
So for production, it's usually down to MySQL or PostgreSQL.
Often, yes. MySQL is hugely popular, generally easy to use, good security features, known for speed, especially on reads, though others are catching up. It has strong replication features, which is great for scaling and backups.
Downsides to MySQL.
It's not always perfectly SQL compliant, and historically could struggle a bit with really heavy concurrent write operations, though it's improved a lot.
And PostgreSQL. I hear that's a big favorite in the Rails world now.
It really is. Often called the most advanced open-source relational database, it's highly extensible, very strict about SQL standards, and packed with features.
Like what kind of features?
Things like really robust JSON-B support for storing and querying JSON efficiently, materialized views, powerful indexing options, and excellent concurrency handling thanks to MVCC, multi-version concurrency control. It's really strong on data integrity, great for complex apps, data warehousing.
Any reason not to use Postgres?
Maybe overkill for very simple apps.
Yeah.
And its replication features, while now very robust, were perhaps historically newer than MySQL's, though that's less of a concern today.
That Reddit discussion we saw definitely leaned heavily towards PostgreSQL for production Rails apps, didn't it? Especially on platforms like Heroku.
Yeah, that seemed to be the strong consensus lately. People mentioned how easy it is to run Postgres locally using Docker too, which helps bridge the dev-prod gap.
Right. Because using SQLite in development and Postgres in production can cause problems.
It absolutely can. There are subtle differences in SQL syntax, data type handling, query planning. Things that work fine in SQLite might break or perform terribly in Postgres. It's really best practice to use the same database engine in all your environments, dev, test, and prod.
So that IONOS article guiding people to switch from SQLite to MySQL makes sense, especially highlighting SQLite's concurrency limits under load.
Exactly. As soon as you expect multiple users hitting your app simultaneously, especially writing data, you generally need to move beyond SQLite.
Okay, so database choice matters a lot. What about performance within the ORM layer itself? We looked at that active record versus SQL benchmark. What did that tell us?
Right, so SQL is another popular Ruby ORM, known for being quite performant and flexible. The benchmark compared it against active record, focusing on execution time and memory usage, especially using timescale DB.
And the results? Was SQL faster?
Generally, yes. For simple queries, SQL tended to be faster, though the gap had narrowed in the latest benchmarks. Interestingly, for more complex queries with joins and aggregations, the performance difference was much smaller, and Active Record actually showed better performance for bulk updates.
Okay, so not a clear win either way on speed. What about memory?
That was a clearer difference. Active Record objects consistently use significantly more memory than SQL objects, especially when loading large numbers of records.
That could be a big deal in memory-constrained environments or with huge data sets.
It could, yes. Although Active Record does have tools like findEach to process records in batches, which helps manage memory consumption for large data sets.
And the author of SQL chimed in, right?
Yeah. Jeremy Evans highlighted some design aspects of SQL that contribute to its efficiency. It's worth remembering, though, Benchmarks are one thing, but developer productivity is another. Active Record's deep integration with Rails is a huge plus for many teams.
Did that benchmark mention anything else? Occam's record?
Yes, Occam's record is a gem designed specifically to reduce Active Record's memory footprint, particularly with associations. The benchmark showed it could offer really dramatic memory savings compared to standard Active Record when eager loading associations. Definitely something to look into if memory usage with Active Record is becoming an issue.
Interesting. So ORM choice or optimization depends on your specific needs. Now, that Rails 8 optimization article had a ton of practical advice. What were the key themes?
The big theme was that database performance is crucial for user experience, scalability, and even costs. It mentioned Rails 8 improving query generation, better support for modern database features like JSONB, and better profiling tools.
Where does optimization start?
Fundamentals first. Database design. The article echoed the preference for PostgreSQL as a robust choice for Rails, showing a sample database.iml config. It stressed efficient schema design, avoiding redundancy, using appropriate types like JSONB, and indexing properly, like using GIN indexes for JSONB data.
Right, good schema is foundational. What about optimizing the actual queries Active Record generates?
Big focus there. It covered the classic n+1 query problem where you accidentally make one query to load main objects and then n extra queries to load associated data for each object.
The performance killer.
Exactly. And the solution, includes to tell Active Record to eager load the associations in fewer queries, usually just one or two extra ones.
What else for query optimization?
Using select and pluck. Don't just load the entire object with all its columns if you only need one or two fields. Pluck.id or select.title.author can drastically cut down data transfer and memory use.
Smart. Only fetch what you need.
Yep. And understanding eager load versus lazy loading. Eager load associations you always need, lazy load ones you only need sometimes.
Connection management also came up.
Definitely. Connection pooling, configured via the pool setting in database.eml, is vital under load. The article also mentioned other database.eml settings like reconnect and timeout for resilience.
Any more advanced techniques mentioned?
Yeah, like dropping down to raw SQL using activerecord.base.connection.execute for really complex, performance-critical queries where the ORM might get in the way. Also, using database views, even materialized views, for complex reporting queries, and offloading heavy data processing to background jobs using ActiveJob and something like Sidekick.
And caching. Always important.
Absolutely. Rails built-in query caching within a request, fragment caching in your views for parts that don't change often, standard web performance techniques applied to database-driven content.
How about finding these performance problems in the first place?
Monitoring and debugging tools are key. The bullet gem is great for automatically detecting n+1 queries and unused eager loads during development. And using active support notifications to subscribe to sesql.activerecord events lets you log and analyze every single query's performance.
Even migrations can impact performance, right? Especially in big apps.
For sure. The article advised breaking large schema changes into smaller steps, using disable transaction carefully for certain operations on Postgres, and adding indexes concurrently, algorithm.concurrently, to avoid locking the table during the index build on production systems. Also, writing reversible migrations is crucial for rollbacks.
And finally, scaling beyond a single database server.
Touched on that too. Mentioned database sharding and partitioning for truly massive datasets, and using read replicas having separate database copies just for handling read queries to distribute load. It even showed an example database.amll setup for primary and replica connections in Rails.
Wow, that's a dense set of optimizations.
Yeah.
Okay, let's connect this to the real world with that Microsoft interview about scaling Flipgrid or Flip. Scaling Rails and Postgres to millions of users. What were the big lessons there?
That interview was gold. It really highlighted the practical challenges of scaling a high-traffic app with social features, likes, views, comments, all hitting a relational database like Postgres.
What kind of challenges?
The sheer concurrency. How do you handle updating a view counter potentially millions of times without creating bottlenecks? There's this tension between the strong consistency guarantees of relational databases and the raw performance needed at massive scale.
Did they mention specific patterns that stress relational databases faster?
Yeah, things like real-time applications, very high ingestion rates like rapidly incoming video data, and those highly interconnected social graph interactions. These can push the limits sooner.
So what do they do about it?
One key strategy was running multiple database instances to segregate traffic, specifically using read replicas.
We just heard about those.
Right. They used PostgreSQL's replication features, physical and logical, extensively to create read-only copies of the database. This allowed them to offload the vast majority of read queries away from the main writable primary database. They noted cloud advances have really minimized replication lag, too.
What about connection pooling at that scale? Did they need external tools?
Interestingly, no. While they acknowledged tools like PGIT Bouncer exist, they found that Rails' built-in application-level connection pooling was generally sufficient, even handling millions of users with Postgres.
How do they approach finding performance issues?
Both reactively fixing problems as they arose and proactively constantly monitoring. Common early bottlenecks were slow queries, high CPU or memory usage on the database servers, and just fetching data inefficiently, like N+1s.
Did they mention counter caches?
Yes, definitely. For things like view counts or comment counts that are read very often but updated slightly less often, using counter caches on the parent object, like the video, avoids hitting the database with expensive count queries repeatedly.
And configuring Rails to use those read replicas. Was that complex?
They said Rails has built-in support that makes it relatively straightforward to configure your app to automatically send writes to the primary and reads to the replicas.
What about scaling writes or handling huge amounts of data for different customers?
They mentioned active record sharding support. This allows horizontal scaling at the application level, partitioning data across multiple independent databases. Useful, for example, in B2B apps to potentially put different customers on different database shards, especially if they have vastly different data volumes but similar schemas.
They also reinforced that point about only selecting needed data, right?
Yes, with a great example. They had a table with like 75 columns, including a big JSON field. A high-traffic query only needed maybe half those columns, but was pulling everything, including the large JSON. Just changing the query to select only the necessary columns significantly reduced data transfer and serialization overhead, boosting performance.
And indexes, of course. Always indexes.
Absolutely critical for reads. But they stress the trade-offs. Indexes slow down writes and take up storage space.
What about unused indexes?
That was a key point. Unused indexes are pure overhead. They slow down writes, consume disk space, increase backup restore times, and can even cost more money in the cloud, like AWS RDS storage costs.
So best practice is to find and remove them.
Yes, monitor index usage. Postgres has tools for this. Identify indexes that aren't being hit by queries and carefully plan their removal, ideally during off-peak hours.
Lastly, they talk about the PostgreSQL Query Planner. Why should a Rails dev care about that?
Understanding the query planner, how Postgres decides the best way to execute your SQL query, is super valuable. It helps you understand why a query is slow and whether your indexes are being used effectively.
How does it make decisions?
Based on statistics, it keeps about your data distribution. That's why running Analyze regularly is important, especially on tables with lots of changes, so the planner has accurate info to work with. If stats are stale, it might choose a bad plan.
Any final debugging tips from that scaling experience?
Yeah. Really understand what data your query is touching. Use explain or explain analyze to see the query plan and check if indexes are being used. Be wary of queries without where clauses or complex joins that might scan huge amounts of data. Understand the cost numbers in the explain plan.
They mentioned a book, too.
Yes, Efficient Rails with Postgres. Highly recommended for digging deeper into these topics and relevant even if you're not using Rails but are using Postgres with another framework.
Wow, okay. That truly was a deep dive. We've gone from active record basics right through to scaling strategies for massive applications.
We really covered a lot, from how Active Record simplifies database work in Rails, to choosing the right database like SQLite versus MySQL versus Postgres, and then tons of performance considerations, query optimization, indexing, caching, scaling with replicas, sharding.
Yeah, a whole toolkit.
Exactly.
So for everyone listening, we definitely recommend checking out those source materials we mentioned, the Rails guides, the benchmarks, the comparison articles, that Reddit thread, the optimization piece, the Microsoft scaling interview. Dig deeper into what's most relevant for you.
For sure. And maybe it leaves you with a final thought to chew on. If you really dig into how your specific application interacts with its database using these tools and techniques, where could you find significant performance wins? Or maybe even save some money on infrastructure?
That's a great question to ponder. How much performance is being left on the table right now?
Worth thinking about.
Absolutely. We'd love to hear any thoughts or questions that came up from this. But until next time, keep exploring, keep optimizing.
Happy coding.